This video is for August 6th, August, I wish. April 6th, April 7th. We're solving logarithmic equations using properties of logs and what we know from going log to exponential, exponential to log. All right, let's look here. Let's say we want to solve this equation. Now, it looks very similar to what happened here. If we looked at the last video, we said if the bases are isolated on both sides, what we can do is ignore those and look what's inside of the equation. We can almost do a similar thing here. If we look at the isolation of log to base 7 on both sides, we can essentially take this and say 3x plus 2 is equal to 6 minus x. Yeah, we can do that. There's another way we can do this as well. If you're interested in that, let me know. I can show you. But we can do this. We have the logs isolated on both sides because if this is 5, well then that has to be 5. So we can set both equal to each other. Where this changes if I add 2 outside of the function, it changes it. We can't say this, but we don't have that situation here, so we're good. And we can keep solving it like we would a normal equation and get x equals 1. All right, let's see about this one. Here, a lot of ways, two different ways we could approach this equation. I'm going to actually show both ways and then talk about what's happening. So the first way is, hey, we already have a log isolated with a value over here. It'd be great if we could turn it into a form where the x is not inside of our log. And we can. What we can do is, if we have a log isolated with a value on the other side, we could turn this into an exponential equation. And the way that we could do that is say 2, our base, raised to the 6th, opposite of log will be our exponent, is x plus 3 squared. Now we have an equation we know how to solve, and we can continue doing that. 2 raised to the 6th would give us 64. If we take the square root of both sides to get x alone, get rid of the square. If we do take the square root of both sides, we do need positive and negative 8. If we do the positive 8, we have 8 equals x plus 3. Subtract 3, we get x equals 5. Negative 8 equals x plus 3, subtract 3, and x equals negative 11. So that is one way that we can change this to an exponential equation and solve. I recommend this way, and you'll see why in a second. Now, another thing we can do, and a lot of students did this, is say, hey, well, we just talked about properties of logarithms, and we have a power inside of our logarithm, so why not move that power out and move it in front, which is doable. We can do this. We want to isolate the log, so we can do that by dividing by 2. Now we've isolated the log. Once we isolate the log, now we can move it to the exponential form. If we move it to its equivalent exponential form, our base here is 2, our exponent is 3, and what's outside would be x plus 3 on the other side. 2 raised to the 3rd would give us 8. And we get x equals 5. Now what about this negative 11? Here's what's happening with that. Because we're this is a good place to talk about it. For our log functions, when we graph them, we said our domain is 0 to infinity for our log functions, which means we only can have positive values actually inside of our logarithm. So when we did that, we said, hey, the negative 11 doesn't work. It's negative. Well, let's check, right? Here, if we do the 5 plus 3 would give you 8 squared, which is what's inside of our logarithm. 8 squared gives you a positive 64. So the 5 does work. The 5 does work. Here, if I plug in negative 11, negative 11 plus 3 gives me negative 8. Negative 8 squared, still positive 64, so negative 11 also works. That does as well. So then I had a lot of students mad at me. I was mad because I was like, what the heck is happening? And I realized something. Here, if it's squared, it doesn't matter if this value is positive, which is what we saw here, or negative. Here, we only consider the positive version by doing the power rule. If we do the negative version as well, we would also need to solve this equation. 2 log base 2 and make everything negative inside. So instead of x plus 3, negative x minus 3. And then if you solve this the same way we did here, you would end up with negative 11. Now, that's just a technicality that I feel like I needed to cover. If you solved it this way on an assessment and got x equals 5, would I count off? No, because I think this is a good way of solving. If you guys did this way and got both solutions, even better, right? The key thing here is that we can solve it multiple ways. Some ways we have to be careful. Would I give you a problem like this? No. But, you know, we just need to be careful in terms of solving and know that we can solve in multiple ways. Now, I'm going to pause this video here, go on to the next video, see how we can solve other logarithmic equations, give you some solutions, and then we'll go from there.